Welcome student. Today I am going our last part in our PMI chapter. Yes students, principle of mathematical induction. In the last part, just a few illustrations. But these illustrations are very most IMP for exam level. So let's start in the example 3. Prove that for every n greater than or equal to 1, just applying this LHS is equal to RHS. So we going to a step 1. Same rule. If n is equal to 1. So what is your LHS? 1 below 1 into 2. And RHS. Same doing. M upon n plus 1. Just n apply 1. You getting just equality. LHS is equal to what? RHS. So P1 is true. Confirmly step 1 over. Now we going to ahead. Step 2. You know that step 2. If Pk is true. So what is the P of K? Same data write down. T up to. Just n change in K. And is equal to also change. K upon K plus 1 for K belongs to natural. Step 3. To prove P of K plus 1. Only I change. K place K plus 1. So, here 1 upon 2, 3. Same write down. Here change. K plus 1. K plus 2. Is equal to K plus 1, K plus 2. Now I am going ahead LHS, our left hand side part. So what's my LHS? These are same calculations. I just write down there. And K 1 upon K plus 1, K plus 2. Only you think about one back down on this one. Yes, you correct thinking. It is a K and K plus 1. Again rewrite. Whole data. Same as here 1 upon K plus 1. And last step as it is. K plus 1, K plus 2. Yes students, this is the main point now coming here. That is this one. Is our step 2. This one. Direct value put down there and easily complete. It is a K upon K plus 1 and here 1 upon K plus 1, K plus 2 and side by side right because Pk is true. Now students, only take out common. You have to K 1 upon K plus 2 and simplify on each. You getting K square plus 2K plus 1 and that is a perfect square. Yes, definitely you can get in here 1 K plus 1 cancel. Remaining are K plus 1 upon K plus 2. That is your RHS. Check. Surely it is RHS. And last I telling, so P of K plus 1 is true. And last write down 2 as well as statement. After that, if Pk is true, then Pk plus 1 is true. And by PMI, Pn is true for every n belongs to natural number. These two lines I not write down here, but you write down necessarily after these steps. Yes students, here this numerical is over, but main step this one. Pk utilized in the P of K plus 1 solution and happily done. Yes students, now we are going to next one. Now students, we are going ahead slowly. One more example. Example number 4. Prove that it is divisible by 4. Means my answer multiple of 4. Then it is divided. Means 4 1s are, 4 2s are, 4 3s are, 4 4s are. Any multiply by 4. it is sure divisible by 4. So I am going ahead. Our step 1. What is step 1? Pn is your proving 7 raised to n, 3 raised to n is divisible by 4. I just take it. If n is equal to 1, apply on it. 7 raised to 1, 3 raised to 1, 4. Yes, so 4 into 1. It's divisible by 4. So therefore P1 is true. Students, if you get in here 8, then you take in 4 to 0. But divisible by 4, no? Yes. Now step 2. If Pk is true, so what kind of you return P of k? 7 raised to k, 3 raised to k is divisible by 4. Indirectly in other, I again write down that is nothing. It is equal to 4k. Sorry, 4m, for k and m belongs to any natural number. Yes. So now step 3. To prove. What is step 3? P of k plus 1. Only k change in k plus 1. That's the step 3. So here k plus 1. 3 raised to k plus 1. Here is divisible by 4. Now I prove that respectively. Utilize step 2 and happily done our last step. So what is the value? For 7 raised to k plus 1, 3 raised to k plus 1, necessarily I just write down base same, power into change, k and 1. Here same, 3 raised to k, 3 raised to 1. Now students, focus about that power it. This 7 raised to k, 7 raised to k. And that value is what? It is surely 4m plus 3k. This one. And other is same. 3 raised to k into 3. Because pk is true. That principle I utilize terms of pk. So my final value 7 4s are 28. 3 raised to k 7. 3 raised to k 3. These are like term. How much? 7 minus 3? 4. Either you common taking. I just common take out. 7 minus 3. So 28m plus 4 times 3 raised to k. Finally I did divisible by 4. Then 4 common. Remaining are 7m. 3 raised to k. And here write down it is t. Because here suppose 7m plus 3 raised to k is equal to t assumption. For km belongs to natural, t belongs to natural, and any natural number multiply with 4. So sure divisible by 4. Therefore, it is divisible by 4. So we can say P of k plus 1 is true. And last written. So if Pk is true, then what? P of k plus 1 is true. And here ending easily. Last write down by PMI. Pn is true for every m belongs to natural number. Yes students, only main step is this. 7 raised to k, put up there. Because I utilize step 2 and prove that step 3. Yes students, we have done this one. Next I bring next one. Yes, now students, one more numerical for you. It is the most IMP numerical, question number 5 number. And this is your highlight in your notebook also. Most IMP number. Inequality related, generally all numerical are IMP. Prove that for every natural number x greater than minus 1 is condition. That's my Pn. 1 plus, and here 1 plus step 1. If n is equal to 1, apply that. P of 1, only and you are putting 1 plus x raised to 1 is greater than 1 plus 1 into x. Check down. It is your true? Yes, students. Here two meanings are given. One of the greater than, one of the equal. Anyone is true. It means this statement is true. Anyone true. Either greater, either equal. If equal is true. So here write down yes. It is true. So indirectly P1 is true. Our rule over. Now start. If Pk is true. So what the P of k? Yes, given terms in the terms of P of k, I just show down there. P of k 1 plus x raised to k more than 1 plus kx for condition necessary. K belongs to n and where x greater than minus 1 is also INT terms for related our this questions. Now students, I am going ahead to my step 3. Yes. What is the step 3? To prove P of k plus 1. What the change is? K change in k plus 1. Here k plus 1. 1 plus k plus 1 into x. And now I start slowly my proving. So here I start. For 1 plus x raised to k plus 1. Can you write down raised to k and raised to 1? Yes, definitely. Now students, this value already write down here. It is my step 2 from, so greater than or equal to, here I just mentioned 1 plus kx. Other same, and here also same as. Now you are going to greater than or equal to, and mention here because Pk is true. So 1 plus x raised to k plus 1 is greater than or equal to 1 plus x plus kx square. Now check. This answer is your proving data? No, but I write down there. Yes, it's the value for kx square. This I write. After that I prove why it is written. But here you show that it is 1 plus k plus 1 into x, and here write down our verification. Why I mention here these steps? Verification very easy. 1 plus x plus kx square is greater than. Students, simple, you applying expansion. It's very simple. So greater than or equal to 1 plus kx plus x. Check left side, right side term value. I translate to left side. So minus 1, minus kx, minus x. Check this again. Only we have to kx here. And here students, there is a main step coming. Condition. For k natural, x more than minus 1. It means students, this is your number line. Here minus 1, 0, 1, 2. You making here square. Can we suggest square for this data? Yes, definitely. If you taking square, minimum number is your 0 and maximum number many numbers. So I start in this range. Here making square. Definitely minimum number is sure 0 and maximum to 0.1, 0.2, 0.3, any up to infinity. So that's why correct to both. Kx square is greater than or equal to 0 is true. It means this condition is true. It means that one is true. So last I ended these steps. After that, you necessarily write down what you prove. Yes, this I prove. After that, these steps, this condition again write down. 1 plus x raised to k plus 1 is greater than is true. Here only I write down, but now I confirm it is true. So students, we can say k plus 1 is better than 1 plus k plus 1x. And that is your step 3 proving. Therefore, p of k plus 1 is true. So last write down, if pk is true, then p of k plus 1 is also true. Last write down as usual by PMI. Pn is true for every n belongs to natural number. Main step this one only. Yes students, here over this example. Now I am going ahead next one. Yes students, now slowly one more question I explain you. 6th one. Example 6. That is also exam oriented. Most IMP numerical. Prove that is whole Pn divisible by 24. It is multiple of 24. Yes students, same I explain you. Here your P of n. 2 into 7 is to n. 3 into 5 is to n minus 5 is, this is my data, divisible by 24. So I just going over step 1. If n equal to 1. So what kind of a region P of 1? 2 into 7 is to 1. 3 into 5 is to 1. Minus 5. 7 to the 14. 5 to the 15. Yes. It gets 10 and 14. 24. Surely you can show 24 into 1. It is divisible by 24. So definitely you can write down P1 is true. Yes students, here first data finished. Continue step 2. If pk is true, so what is the p of k? So 2 into 7 raised to k, 3 into 5 raised to k, minus 5, same written, is divisible by 24 for k belongs to natural. And what is the meaning for that? It is meaning just only divisible 24. So we can say 24 into m for again m is natural number. So now step 3 to prove. So what is the to prove? Same data write down, only I change in place of k plus 1. Yes. Here 7 raised to k plus 1. Same here 5 raised to k plus 1. Minus 5 is divisible by 24. And here I start my easy solution. So my calculation start here for the value. 2 into 7 to the power k plus 1. 3 into 5 to the power k plus 1. Minus 5 is equal to only power decay change in the terms of our step 2. So 2 into 7 raised to k, 7 raised to 1. 3 into 5 raised to k, 5 raised to 1. And minus 5 as usual. Students, these are the 7 to the 30. 5 3 is a 50. So I just write down. After that, here now 7 to the 14, 7 raised to k, 5 to the 15, 5 raised to k, and minus 5. Students, now again I same explanation. You putting value 7 to the power k from step 2, either 5 raised to k here and there. Any one data you translate them and value put it. 14 as usual. What is the 7 raised to k here? 24n plus 5 minus 3 into 5 raised to k by 2. One more time. This value, it's actually coming from here. This term I take right side and these two are divided there. Then we divide 7 raised to k. And other 15 with 5 raised to k same. minus 5 same here. Declare. Because pk is true. That side. Complete now. Easily. 2 sevens are. Here 7 into 24m. 7 5s are 35. 7 3s are 21. And last 15 to 5 is to k. Students, here we are checking the common. So 7 with 24m, 35 same, and what value? Here these are remaining minus 6. Yes, 7 5 are 35, 21, 15 and minus 5. 35 minus 5, it gets 30. And here just common taking 5 is to k, minus 21 plus 15. That also known. What is that? It is minus 6. Yes students, this part particular I explain now. Because I want to divisible 24. Here 24 divisible. But here I prove. So that value I just explain. Suggestion by something T. Yes. Suppose T is equal to 30 plus 5 is to k minus 6. And what is the k? Every natural number. So if k is 1, then what is the t? 30 plus 5 is to 1 minus 6. Here t value, k value is 1. So 6 5s are 30. Indirectly it is 0. Sure 0 is divisible by 24? Yes. It is divisible by 24. One more explaining. If k equal to 2, then what is the t? 30 plus 5 is to 2 minus 6. 25 6 are 150. So 30 minus 150. It get minus 120. Check. This 120 is divisible by 24. Yes again. It is divisible by 24. If you take a k equal to 3, then also divisible after that calculation. It means finally, students, what we derive? We deriving this value is divisible by 24. So finally, I just write down 2 into this statement are again written 7 raised to k plus 1. 3 into 5 raised to k plus 1 minus 5 is equal to, this steps all after that proving that one, 7 into 24m plus 3 is divisible by 24. Students, why written? This t already divisible 24 for any natural number, and this also already 24 common. Indirectly full data divisible 24. So yes, p of k plus 1 is true. And last write down, if pk is true, then p of k plus 1 is also true. And last written by Tn is true for every n belongs to natural number. Students, this step necessary showing because I just proved this p value is a multiple of 24. For further taking k1 and k2 only. Other all have natural number already written there. Yes students, now I am going to next example. Yes students, after ending our 6th example, I move ahead 7. 7 also tick mark in IMP list because inequality given and inequality related. Students, IMP question. Yes. So highlight, these are the most IMP and start step 1. That is your P of n. Consider your question is P of n. Step 1. If n is equal to 1. So what is the P of n I just written? 1 square plus 2 square plus 3 square and cube by 3. But I written if you P1. Only one write down here. Greater than 1 cube by 3. This is the first step taking, and here right side value taking. And check down. 3 more than 1. Yes, it is true. I only carry forward 3 upper side. So P1 is true. Happily done. Now step 2. What is step 2? If Pk is true. So what is the P of K? Same as write down 1 square, 2 square, 3 square. Up to K square is greater than K cube by 3. And for K belongs to natural. Continue step 3, which is to prove P of K plus 1. So 1 square, 2 square, 3 square. And what is the changes now? Only K. Changing K plus 1. So here students, K plus 1 changing by 3. And here starts my now proving. Proving very simple and very easy. So for I start 1 square, 2 square, 3 square is a K plus 1 square is equal to. Just here think about one back term. Yes students, you correct thinking. What is back term? 1 less. So 1 square, 2 square, 3 square. Here K square. And K plus 1 whole square is same. And this value I just highlight again for you. That is the step number 2. You also highlight in your notebook for better understanding. And that value is what? Greater than K cube by 3. Here same. And you have written because Pk is true. This is the same written. 1 square, 2 square, 3 square, K plus 1 square. Now check this answer. Is actually proving you? No. I just now going ahead to that kind of thing. So students, this are again right 1 square, 2 square, 3 square. K plus 1 whole square is greater than that quantity. K cube by 3 plus K plus 1 whole square. And I proving that these are step 3. It is greater than K plus 1 cube by 3. And after that I write it's the verification. Why I written this? Yes, verification must be write down. So K cube by 3 plus K plus 1 whole square is greater than by 3. Students, this value expansion simplify and must be I prove it is yet true. So this data is true. So K cube 3, just I take LCM and expand. Greater than K cube plus 1 cube. 3 into K into 1. K plus 1. I here written A plus B the whole raised to 3. You know the formula. Is it gone? So K raised to 3. 3K square. 6K plus 3. And here greater than K cube plus 1. 3K square and 3K terms. Take right side. Now in the left hand side. So K cube 3K square 6K plus 3 minus K cube minus 1 minus 3K square minus 3K greater than 0. Students, this all value I just right side convert left side. So this cancel. Yes, that also cancel. You correct thinking. 6K minus 3K? 3K plus 2 greater than 0 is true for every K belongs to natural. Why it is true? Check. Natural number apply here. K is 1. Sure your answer is 5 greater than 0. True. K equal to 2. Then 6 plus 2 8 greater than 0. It is true. It means any value putting in the natural number. This statement is true. It means this true. It means this true. It means that true. So after that I last showing that steps. fulfilling your verification condition, you necessarily line this to calculate and showing that, so 1 square plus 2 square 3 square, k plus 1 whole square is greater than k cube by 3 whole square is greater than k plus 1 cube by 3 is true. Actually here not true, I just write down because I prove that. But now after this condition we can confirmly say it is true. So I again write this full value k plus 1 whole square is greater than that one, k plus 1 whole cube by 3. And students, this is your final step. We conclude here this one. Yes, now easy. Therefore, P of k plus 1 is true. Therefore, if Pk is true, then P of k plus 1 is true. So last write down by Pmi. Pn is true for every n belongs to natural number. Yes, students, here our this numerical is happily I done. Only main step is this. I just utilize and verification wise you going this solution. Yes, students, here are the 7 examples done, and I hope you calculate example 8 itself. I give you example 8 for your self practice. Okay, and here our chapter is over. Yes, students, I hope you understood PMI, principle of mathematical induction, very well. If you have any query, I already given my number here. You just follow that number and WhatsApp me. Okay. Now students, here chapter ending. After that, in next part, I explain you one more interesting chapter. It is a complex number, chapter 5. Okay. See you soon. Bye bye.